Scientific notation is just one of those things that we need to know something about. It kind of just, it's not going to get tested on its own, but it'll get tested in other questions. So it's a way of writing very big and very small numbers. You write the units digit, a decimal place, 1 or 2 decimal places, times 10 to the power of something or other. So, for example, 3,45 times 10 to the power of positive 5. Or, that's a number bigger than 1. 7,26 times 10 to the negative 12 means it's a number much smaller than 1. So if I had 2,000, it really means 2 times 1,000, which is 2 times 10 to the power of 3. 0,04, hop the comma over 1, 2, 3 places. It's the same as 4 divided by 1,000, which is 4 divided by 10 to the power of 3. But we don't have a divide, we have to times it. And when I times, I tip in times. So I put that at the bottom, the 10 to the negative 3. And then when something's in the denominator, I can use a negative exponent. You know all of this from maths, so it's just the exact same. If I've got a positive exponent on the 10, it tells me that I've got a number larger than 1, because I'm multiplying by that power of 10. But if I've got a negative exponent, it means I'm dividing. Remember in maths, x to the negative 1 really means 1 over x. Press pause, try and get all of these numbers into scientific notation. So, what have you got? The 4 noughts here, so it's 7 times 10 to the power of 4. Move this comma 2 places over, times 10 to the negative 2. Move this comma over 1, 2, 3, 4 places, 10 to the negative 4. Here, I've got a big number. I'm going to move the comma back, 1, 2, 3, 4, 5, 6. So it's 6,44 times 10 to the 6th. You don't normally keep all those decimal places. Hop this comma back twice and you 10 to the positive 2. This one forward, 1, 2, 3, 4, 5 places, 10 to the negative 5. On the last one, you're going to hop back 1, 2, 3, 4, 5, 6, 7, 8 places, and then you land up. You can also just punch those numbers into your calculator, put it into scientific mode, and it will spit out those numbers for you. Where it becomes handy to be able to use, by the way, these will be given in an exam. Some of them will. Normally if they talk about nano and micro and mega and giga, they'll give those to you, and pico. But they're not going to give you kilo and centi and milli. Those there's an expectation that you should know. So what do you got? You've got a capital G is giga, and that is 1 billion. Mega is a million. Kilo is 1,000. At least hecto is 100. Deca is 10, and then you've got the base, which is 10 to the power of 0, which is really 1. Deci is 1/10, centi is 100th, milli is 1,000th, micro is 1 millionth, nano is 1 billionth, and pico is 1 trillionth. So, what if they say to me, convert 6 megawatts into watts? I'm going 1 megawatt is big, 1 watt is little, compared to a megawatt. So, megawatt is bigger than watts. That's what happens to the unit. I then take the number, and if the unit went from big to small, the number will go from small to big. Let's just do that with a normal thing. So if I had 10 millimeters into meters, you know 10 millimeters is much smaller. 1 millimeter is small, and a meter is big. Just think of 1 and 1. So that's the unit. The number then, if I convert this into meters, you know you're going to divide by 1,000, so it's going to be 0,01. 0,01 is a small number when compared to 10, so it will always go in the opposite direction. So the number goes from small to big, so I'm going to multiply. I'm going to take 6, and I'm going to multiply it by 10 to the 6. If I'm converting 17 millimeters into meters, 1 millimeter is small, 1 meter is big. Unit small to big. The number goes from big to small. So I'm going to divide. I take 17, milli is times 10 to the negative 3, times by 10 to the negative 3. Actually, the negative is from this divide, because sometimes I'm going in the opposite direction. And I land up with times 10 to the negative 2 if I punch it into my calculator. 17 times 10 to the negative 3 is 1,7 times 10 to the negative 2 in scientific notation. If I have got 760 picometers, a little picometer is very small. It's the size of an atom, and compared to a meter. So the number is going to go from big to small. That means that I have got to divide. So I divide by 10 to the 12, because pico is 12, and I get 7,6 times 10 to the negative 10. 23 kilograms into grams. 1 kilogram is big compared to 1 gram. So it's big to small. I multiply the number because I have to go the number from small to big. What is kilo? Kilos times 10 to the 3, so I multiply that up. If I punch it into my calculator, I get 2,3 times 10 to the 4. We can try and work through these ones over here in the same way. You can do your working, press pause, and then take a look at the answers. So if I take a look at this, the first one, I need to centimeters to meters divide by 100. Millimeters to hectometers, first I need to get to meters. So I'm going to go to 100, at least divide by 1,000. And then I have to say, well, 1 hectometer is 100 meters, so I need to divide by another 100. And I get to 0,007. If I'm going from decimeters to millimeters, I'm going to be hopping up by 10, multiplying by 10, so I multiply by 100 in total. Kilometers to meters is times by 1,000. Then these are important. You need to know how to go from kilometers per hour to meters per second and vice versa. All you do is you say, what does 3 kilometers per hour mean? It means 3 kilometers divided by 1 hour. So I take the kilometers, 3,000 meters, and I divide them by 1 hour, which is 3,600 seconds. Boink, out comes my answer. If I've got 17 meters per second, that is 0,017 kilometers per 1 hour. A second in hours is 1/3,600th of an hour. And when I punch that into my calculator, which I do by going 0,017 times by 3,600, I get 61,2.